So now let's do some more questions related to circles. Okay, area related to circles, right? So look at this question, question number 5. Area of a sector of a circle of radius 36 centimeter is 54 pi centimeter square. Find the length of the corresponding arc of the sector. Okay, so as you can see here, the diagram, right? So this is a circle, okay, and there is a sector OAB, right? So this is the sector OAB, right? Now, radius is already given here, 36 centimeter, OA and AB, OA and OB, right? Area of this sector is 54 pi centimeter square. Now we have to find the length, this length of arc AB, okay? So now in this question, very first we will write down what is given, okay? Right? So write down area, that is A, area of the sector, area of sector OAB, this is equals to 54 pi centimeter square, okay? Radius, radius is also given, that is 36 centimeter, right? Now we have to find the length of the arc, right? So length of the arc is suppose L. L is the length of the arc, length of arc AB, right? Okay. So as we know that there is a relation between A, L and R. A is equals to 1 by 2 L into R, right? So we can use this relation. So using the relation A is equal to half L into R, right? Where L is the length of the arc, R is the radius, okay? And A is the area of the sector of that circle, right? So area is already given here, 54 pi half into L we have to find, and R is 36 centimeter, right? So now in this way you can find the value of L. So L is equals to 54 pi, please be on mute, 54 pi into 2 into 36 into 2 divided by 36, okay, right? So this is 18.3, right? Okay, so you can see that L is equals to 3 pi. Okay, so we have pi also here. L is equals to 3 pi centimeter. Okay, so in this way we can get the value of L, that means length of the arc, that is AB. You can also write it down in decimals, right? Just put the value of pi, 3.14 into 3, right? Okay, and that will be the value of L in decimals. Okay, so in this way we can find out the length of the arc if radius is given and if area is given, right? We can directly use the formula. Okay, so this question is also given in your Ncert exemplar. Okay, other way is to find out the theta, right? First you can find out the theta and then you can find out the length of the arc. Okay, please note it down. So let's see the other method of doing the same question, right? By finding out the theta. Other method, right? So we can first find out the central angle here, right? This theta. Suppose this is theta, the angle of the sector, that is the central angle. Okay, we can first find out the theta, provided R is already given, 36 centimeter. Okay, and area of the sector is 54 pi centimeter square. Okay, so as we know that area of a sector of a circle is it is given as theta upon 360 into pi r square, right? Area is already given, so we can write down here for 54 pi. Okay, this is equal to theta upon 360 into pi into r square. R is 36 here, radius is 36, so 36 square, right? Pi will cancel, right? So now theta will be equal to 360 upon 36 into 36 into 54, right? Okay, so 54 into 360 upon 36 into 36. Now you can find it out, right? So this is 10, right? 540 divided by 36 is what? 15, right? 540 divided by 36. This is 15. Okay. So in this way, we have got the value of theta, means angle of the sector, means central angle, that is 15 degree. This is the central angle, right? Okay. Now, since theta is, now we know the theta, the value of the theta, we can find out the length, right? So length of the arc, length of an arc AB of sector OAB. This is given by theta upon 360 into 2 pi r, right? Now here we can put the value of theta, which we have calculated. Theta is 15 degree upon 360 into 2 pi into r. R is 36 centimeter, right? So in this way we can do this. So this is 10, 2, 5, 5 and 3. So this will be equal to 3 pi, right? So you can see here that we are getting L, that is 3 pi centimeter. So in both the ways, you will get the same answer, whether you do this way, or you can also do it directly by the relation of A, L and R, right? Okay, so with both the ways, you will get the same answer. So now look at this question, another one, question number 6. Find the difference of the areas of a sector of angle 120 degree and its corresponding major sector of a circle of radius 21 centimeters, right? So as you can see here in the diagram, we have a circle of center O, right? Radius is 21 centimeters, right? OA and OB are the radius. And the sector OAB having central angle 120 degree, okay? This is the minor sector. So let's suppose the area of this minor sector is A1 and the other one is the major sector, and suppose the area of this major sector is suppose A2, right? Now, what we have to do here, we have to find the area of the minor sector provided the central angle theta 120 degree and radius of the circle is 21 centimeter, right? So once we get this area of the minor sector, we can find the area of the major sector and then we can find out the difference between the two, right? Okay, so let's do it. First, write down what is given. So R is equals to 21 centimeters, okay, and theta is 120 degree, right? Now suppose A1 is the area of the sector A1, that is area of sector OAB, okay, this is equal to theta upon 360 degree into pi r square, right? Now you can put the values here. Theta is 120 degree upon 360 into pi into r square. R is 21, 21 square, right? Is it clear? So this is 21 into 21 into pi upon 3, right? That is 7. So this is equal to 147 pi centimeter square. So in this way, we have got A1. We have got A1, which is equals to 147 pi centimeter square, right? So this is the area of the minor sector, right? As you can see in the diagram, this is the area of the minor sector. Now we can find out the area of the major sector. Okay, how we can find it out? Area of the major sector, area of major sector is suppose A2, right? And this is equal to area of the circle minus area of the minor sector. Okay, so the minor sector here is OAB and its area is A1, right? Okay, now we can put the value here. This is pi r square minus 147 pi, right? This will be your A2. Is that clear? Pi r square minus 147 pi. Okay, now we can take pi common. So this will be equal to r square. R is 21. Okay, so this is equal to 21 square minus 147. Okay, 21 square is 441. 441 minus 147. So this is equal to 294. 441 minus 147 is 294, right? So in this way, we have got A2, that is 294 pi centimeter square, right? So in this way, we have got the area of minor and major sector both, right? Now we can find out the difference between the two, right? So write down required difference that is A2 minus A1. This is equal to 294 pi, which is A2, minus 147 pi, which is A1, right? So we can find out the difference, and this is equal to 147 pi centimeter square. Now you can also put the value of pi here, that is 22 by 7. Okay, now solve this. 147 can be divided by 7, right? It will go for 21 times, right? So 21 into 22, that is 462. Right? So in this way, we have got the difference A2 minus A1, which is 462 centimeter square, right? So in this way, we have got this difference between the major and the minor sector. So what we have done, we have first find it out the area of the minor sector, because theta is given, r is given, right? After finding out the A1, the area of the minor sector, we can subtract this from the area of the whole circle, pi r square, to get the area of the major sector. And now we can find out the difference, that is A2 minus A1. So I hope now you have understood this, yes or no? Now look at this another question, be on mute. Question number 7. AB and CD are respectively the two arcs of the concentric circles of radii 21 centimeter and 7 centimeter with center O, right? If angle AOB is 30 degree, find the area of the shaded region. As you can see here, we have drawn the diagram, right? So OA, OB, right? Okay, these are the radii of the bigger circle, and AB is the arc, right, of the bigger circle. Similarly, CD is the arc of the smaller one. Okay, so AB and CD are the arc of the two circles, right? And angle is 30 degree, which is at the center O. They are concentric circles, so having the same center O, right? And angle this AOB is 30 degree, which is given here. Now we have to find the area which is occupied by this shaded region, right? So how to do this? We can find out the area of both the sectors, right? AOB and COD, right? And then we can subtract them to get the area of the shaded region, right? So just write down.
How
Okay.
is it 112 centimeters square?
Wait, I'm telling you. So area of shaded region, this is equal to area of sector OAB, minus area of sector OCD. Okay, right? In this way, we can get the area of the shaded region. Now, what is given here? Radius is given. Okay, R, R1, R2, both are given, right? So OA, you can see OA is 21 centimeter and OC is 7 centimeter, right? And angle theta is 30 degree. Now we can put the values now. So area of shaded region, this will be equal to area of sector OAB. So area of sector OAB will be theta upon 360 into pi r square, right? Suppose this r we have taken as capital R, and this can be taken as a small r, right? So we can do it like theta upon 360 pi r square minus theta upon 360 into pi small r square, right? This is the area of sector OCD, right? Now put the values 30 upon 360 into pi 22/7 into r square, right? So capital R is 21, so 21 square minus theta, that is 30 degree, upon 360 into pi 22/7 into r, right? Small r, which is 7 centimeter here. So this is 7 square. So now we can take 30 upon 360 into 22/7 common, right? And this will be equal to 21 square minus 7 square. Getting that? So now you can solve this. This will be equal to 12, right? 11, 6. So this will be equal to 11 upon 42 into, now 21 square is, you can write down 21 square minus 7 square as 21 plus a, means 21 plus 7, and 21 minus 7, a plus b, a minus b, right? So this will be equal to 28 into 14, right? Okay, so now you can solve this. Okay, and this is equal to 11 into 28 upon 3. Now solve it. So this is 308 upon 3. That is 102.66 something, right? Okay, so you can approximately take it as 102.67 centimeter square. So in this way, we have got the area of the shaded region. So this is the area of shaded region. Okay, so what we have done, this is your answer. So what we have done, we have subtracted the area of the bigger sector from the area of the smaller sector from the area of the bigger sector to get the area of this shaded portion. Is that clear? Yes or no? Now look at this question number 8, another one. The length of minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 1 minute, right? So we have to find what will be the area which is swept by minute hand in 1 minute, right? So as we know that minute hand of a clock describes a circle of radius equal to its length, right? That is 14 centimeter, right? So what is the length of the minute hand? That is 14 centimeter, right? Okay. So the circle which it will describe is having the radius equal to its length only. Yes or no? Okay. So R is 14 centimeter equal to the length of the minute hand, right? Now, since the minute hand rotates through 6 degree in 1 minute, yes or no? How much it rotates? Like 360 degree. In how much time it will rotate 360 degree, the minute hand? Can you tell me? So angle described by the minute hand in 60 minutes is 360 degree. Yes or no? So write down angle described by minute hand in 60 minutes. So in 60 minutes, how much angle it will describe? That is complete angle, 360 degree. Is that clear? So what will be the angle described by minute hand in 1 minute? You can find out by the unitary method. So angle described by minute hand in 1 minute. This will be equal to, tell me, 360 upon 60, right? Okay, that is 6 degrees, right? So how much angle it will describe in 1 minute, the minute hand in 1 minute? That is 6 degree. Is that clear? So area swept by the minute hand in 1 minute is the area of the sector of the angle 60 degree. Is that clear? Right? So that means if we draw a circle here, right? And suppose this is the area described by the minute hand, right? Okay. then how much area it will describe in 1 minute? That is 6 degrees. So what will be your 6 degree? That will be your theta, right? So this is your theta, 6 degree. Okay. So theta is 6 degrees, right? And what will be the radius? Radius will be equal to the length of the minute hand, that is 14 centimeter. Okay. So R is 14 centimeter. Now we can find out the area. So area swept by minute hand in 1 minute. Okay, so this will be equal to AOB, or you can say OAB, right, in the figure. And this will be equal to theta upon 360 into pi r square, right, according to the formula. Now we can put the values here. Theta is 6, 6 upon 60, 360 into pi, 22 by 7. Into r square. R is 14, so this is 14 into 14. So now you can calculate this. So this will become 62, right, 30, 15, 11, right? So this is equal to 11 into 14 upon 15, right? That is 154 upon 15. That is equal to 10.26 centimeter square, right? So this is the area which is swept by minute hand in 1 minute. So this is your answer, right? So in this way we can find this. I hope you have understood. Yes or no? Look at this question, question number 9. In a circle with center O and radius 5 centimeter, AB is a chord of length 5 root 3 centimeter. Find the area of the sector AOB, right? So now within this circle, center is O, right? Okay. Radius is 5 centimeter. OA and OB are 5 centimeter. And the length of the chord AB is 5 root 3 centimeter. Now we have to find the area of this sector AOB, right? So here angle is not given. Angle of the sector is not given. So we need to first find out the angle of the sector, and length of the arc AB is also not given. Length of the chord is given. Arc length is not given here, right? So what we will do here, since it is given that AB, the length of the chord, is 5 root 3 centimeter. Okay, right? So what we have done, as you can see here in the diagram, we have drawn a perpendicular line from the center on this chord, right? And suppose it cuts the AB at point L, right? So it will bisect the chord. Okay, these theorems we have already done earlier, right? So whenever there is a chord and we draw a perpendicular from the center, right, it will bisect the chord into two equal half, right? So therefore we can say that AL will be equal to BL, and this will be equal to half of AB, right? Okay, and AB is 5 root 3. So we can say that this is equal to ALBL is equal to 5 root 3 upon 2 centimeters, right? Okay. Now, if suppose this is theta and this is theta, right? Okay. Now let angle AOB is equal to 2 theta, right? Theta plus theta, right? So angle AOL will be equal to angle BOL, that is theta, right? Okay. Both angles are equal, right? Now in triangle OLA, consider the triangle OLA, right? So what we have, sine theta, this is a right angle triangle. OLA is a right angle triangle, right angle at point L. Okay, is that clear? Right? So we can say that sine theta here in this triangle will be equal to AL upon OA, AL upon OA, right? Perpendicular upon hypotenuse, right? So this is perpendicular and this is hypotenuse. Okay, is that clear? Now we can put the values here. AL is what? AL we have already calculated 5 root 3 upon 2. So write down 5 upon 5 root 3 upon 2 upon OA. What is OA? OA is the radius, 5 centimeter. So write down 5 here, right? Okay. So this will cut. So this is equal to root 3 by 2, right? Now, what is root 3 by 2? When sine theta is root 3 by 2, what is the value of theta? Sine theta is coming root 3 by 2. That means what is the value of theta? Theta is 60 degree, right? So in this way, we have calculated the value of theta, that is 60 degree, right? So if theta is 60 degree, then angle AOB, this complete angle, this whole angle, theta plus theta will be 120 degree, right? So write down, therefore, angle AOB is equal to 2 theta, that is 2 into 60 degree, that is 120 degree, right? So angle AOB is 120 degree. So what we have calculated? We have calculated the angle of the sector OAB, right? Now we can easily find the area of this sector, right? So write down area of sector AOB. This is equal to 120 degree, means the angle AOB upon 360 degree into pi r square, pi into r square. R is 5, that is 5 square. Radius is 5 here. Okay. So now you can calculate this 3, right? So this is equal to 5 square pi upon 3, that is 25 pi upon 3 centimeter square, right? Is that clear? So you can also find this in decimals by putting the value of pi, and you can calculate this. So this will be equal to 25 by 3 into 22 by 7, right? So this is equal to approximately 26.19 centimeter square. So in this way, we have got the area of sector AOB. So what we have done, because here theta means the central angle of the sector is not given. So first we have find it out by using the right angle triangle, right? Okay, by using the trigonometric ratio, and then we have calculated the area of the given sector. So I hope you have understood this. Please note it down.